Hello and welcome to a new episode of Quantum Physics for Beginners. Today we're going to talk about quantum entanglement. I think that a great way to start off the journey into learning more about quantum physics is starting with quantum entanglement, because it is the key concept to understanding quantum physics and it relates to every other topic in quantum physics. Quantum entanglement is when two or more particles become connected at a subatomic level. An example of this is if you roll two dice and they both come up with the number 6. These two particles, represented by the dice, are telepathically communicating to each other faster than the speed of light, and telling each other what they're going to do before someone can observe them. So these two particles are communicating with each other, telling them what they're going to do, what the outcome is going to be, how they're going to act. And due to the observer effect, a scientist cannot observe that this is happening, and that's why the two particles are acting the same. I will discuss in my following video about the observer effect, so follow my page to view more videos. Hello and welcome to a new episode of A Beginner's Guide to Quantum Physics. Today I will be talking about quantum tunneling. To have a greater understanding of this concept, I strongly suggest that you watch my other videos. Quantum tunneling is when a particle can penetrate an energy barrier that's higher than its own kinetic energy. In simpler terms, this means that a particle can move through an object that contains more kinetic energy than itself. Kinetic energy is the energy an object has when it is in motion. An example of quantum tunneling is a particle traveling through a door. Theoretically, in the quantum physical realm, which is the space between the electron shells of an atom, particles are capable of quantum tunneling. Hello and welcome to a new video of the basics of quantum physics. Today I will be discussing wave-particle duality, which is when waves can exhibit particle-like properties, while particles can exhibit wave-like properties. For example, fundamental entities like light and electrons can behave both like a wave and a particle. A way that scientists test this is through the double-slit experiment. The double-slit experiment shows that when particles are sent through two slits, these particles can create an interference pattern, which is a series of bright and dark bands. This only happens when a scientist observes them, whereas when a scientist does not observe the particles passing through the double slits, the particles behave like particles and only go through one slit. Therefore, the particles act both as a wave and a particle. Discuss the observer effect. So this is simply when observing a situation can alter it. If you haven't already seen my video on quantum entanglement, I strongly suggest you watch that video before this one. A common example of this is the double slit experiment. When observing electrons being fired at two slits, they behave like waves and create an interference pattern, suggesting that they pass through both slits simultaneously. Whereas when the electrons are not being observed, the interference patterns disappear and the electrons behave like particles, going through only one of the slits, which is recorded through a detector. In this experiment, the scientist observing the electron altered the outcome of the study. This is the observer effect. Hello and welcome to the basics of quantum physics. Before I really get into the depth upon the subject, I just wanted to make sure that people understand what quantum physics overall means. Quantum physics is the study or branch of science that deals with how different subatomic particles react with each other. Particles in an atom are protons, electrons, and neutrons. Outside the nucleus of an atom is electron shells. The particles between the electron shells are believed to be quantum particles. Between the electron shells of an atom is equivalent to almost a new world called the quantum physical world. where the laws of classical physics are completely discarded. Hello and welcome back to a new lesson of the basics of quantum physics. Today I will be discussing the Heisenberg uncertainty principle, which is a fundamental law of quantum physics and an aspect of quantum mechanics. The uncertainty principle originated from Werner Heisenberg, states that there is a limit of precision to which certain properties of particles are measured. In simpler terms, this means that scientists are not capable of measuring both the exact position and the exact momentum of a subatomic particle at the same time. The more accurate one property is known, the less accurate the other property is known. The product of this uncertainty always will succeed a particular minimum value related to Planck's constant.